Today I am going to explain Cramer's rule for solving simultaneous equations. So let a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3 are three simultaneous linear equations to be solved. So by Cramer's rule we have to solve them. So let's start. In this method, first we prepare a determinant of the coefficients of x, y, z, that is the determinant a1, b1, c1, a2, b2, c2, a3, b3, c3, and this determinant is denoted by capital D. Next, we need to prepare another determinant in which the first column, that is the column a1, a2, a3 is replaced by these constant terms of the equations d1, d2, d3. If we replace the column 1 by these three elements, we have d1, d2, d3, and rest of the columns are as it is: b1, b2, b3, c1, c2, c3, and this determinant is denoted by capital D1. In the next step, we used to prepare a determinant replacing b1, b2, b3, that is the second column of this determinant, by these constant terms. So we have determinant a1, a2, a3, d1, d2, d3, c1, c2, c3, and this determinant is denoted by d2. Again, this time we have to replace the third column of the first determinant by these constant terms. So we have a1, a2, a3, b1, b2, b3, d1, d2, d3, and this determinant is denoted by capital D3. Now, according to Cramer's rule, x is equal to d1 upon d and y is equal to d2 upon d and z is equal to d3 upon d. So evaluating d, d1, d2, d3, we substitute these values in these three expressions, and in this way we find the value of x, y, z, that is the solution of the given simultaneous equation. Now let's take an example on Cramer's rule. So this is the sum. Solve the following equations by Cramer's rule, and the equations are given as x plus y plus z is equal to 6, x minus y plus z is equal to 2, and 2x plus y minus z is equal to 1. So first, as I have explained in general method, that we used to make first determinant of coefficients of x, y, z, that is 1, 1, 1. I have already written. And second, in the second equation, the coefficients are 1, minus 1, 1. And in the third equation, the coefficients are 2, 1, minus 1. And this is denoted by capital D. So before proceeding, let's evaluate this determinant. So first element of first row 1, then this column and this row vanish. Put the bracket and write the cross multiplication of these 4 elements. Minus 1 into minus 1, 1. Minus between them and 1 into 1, 1. So next element with negative sign, that is minus 1, put a bracket. Now this column and this row vanish. These 4 elements are left. Take the cross multiplication, 1 into minus 1, minus 1. Then minus 2 ones are 2. And the next element take with positive sign, bracket, and then we have to eliminate this column and this row in which this element lies. These 4 elements are left. Take the cross multiplication of these 4 and put a minus sign between them. 1 ones are 1, minus minus 2 minus minus becomes plus, so plus 2. So simplifying this, we get 1 minus 1, 0, minus 1 minus 2 minus 3, and minus 3 into minus 1 plus 3, and here 1 plus 2 is 3, and 3 into 1 is 3 plus 3. So 0 plus 3 plus 3 is equal to 6. So the determinant is not equal to 0, and in this way we come to the conclusion that the given equations are consistent with unique solution. Now we have to make the next determinant, which is denoted by D1, and it is created by replacing the first column of D determinant by these constant terms of the equations. So this column is replaced by these 3. So we have 6, 2, 1, and rest of the columns as these are. So 1 minus 1, 1, 1, 1, minus 1. Just evaluate. 6, this column, this row vanish. Minus into minus plus 1, minus between them, 1 ones are 1, and here next element is minus 1. We put positive, negative, and positive, alternate negative, positives and negative signs to evaluate determinant, as I have explained in the dedicated video for the determinant. So 1, and this column and this row vanish. 2 minus 1 is minus 2, minus 1, and then plus 1. This column, this row vanish. 2 ones are 2, minus into minus plus 1. Now the next, just simplifying this, 6, 1 minus 1, 0, so we get 0, and here minus 2 minus 1 minus 3, so minus into minus plus 3, and here 2 plus 1, 3, so plus 3, so we get 6. Now we have to form D1, which is formed by replacing the second column of D determinant by these constant terms. So 1, 1, 1, 1, 1, 2 in D, and the second column is replaced by 6, 2, 1, and third column as it is 1 minus 1, 1. Sorry, that is 1, 1 minus 1. So this is plus 1. 1, 1, 2, and this is replaced by 6, 2, 1, and this is 1, 1 minus 1. So just evaluate this. 1, first element, and this column and this row vanished, and cross multiply minus 2 in minus 1, and the next element should be taken with the negative sign. 6, this column, this row vanish, minus 1 minus 2, then the next one with the plus sign, 1, and this column, this row vanish, 1 ones are 1, and 2 twos are 4. Let's simplify this. Minus 3 plus 18 minus 3. So we have 18 minus 6, that is equal to 12. Now next we have to form D3, the third determinant, and which is formed by replacing the third column of D by these constant terms in these equations. So first column, that is 1 1 2 as it is, second column 1 minus 1 1 as it is, and the third column is replaced by the constant terms, that is 6 2 1. And now just evaluate this. So 1 bracket, this column, this row vanish, minus 1 minus 2, then with the negative sign the next element 1 bracket, this column, this row vanish, 1 1s are 1, minus 2 2s are 4, then plus next element with the positive sign, then put a bracket, and this column, this row vanish, these 4 elements are left, 1 1s are 1, minus 2, that is plus 2, minus becomes plus, and ultimately we have minus 3 plus 3, because this is minus 3, 1 minus 4, and minus into minus plus, so we get plus 3. So plus, now it becomes 1 plus 2, 3, 3, 6 are 18. Positive 3, negative 3 cancel, and we have 18. So we get D is equal to 6, D1 is equal to 6, D2 is equal to 12, and D3 is equal to 18. Now by Cramer's rule, X is equal to D1 upon D. So substitute the value. D1 is 6 and D is also 6. 6 ones are 6, so we get 1. Y is equal to D2 upon D. Substituting the values we have, D2 is 12 upon D is 6. So we have 12 upon 6, that is 6 2s are 12. And finally Z is equal to D3 upon D, and we have D3 as 18 upon D is 6, so 6 will cancel 18 3 times, 6 3s are 18, and we get 3. So in this way we get X is equal to 1, Y is equal to 2, and Z is equal to 3. This is the required solution of the given simultaneous equations by Cramer's rule.